Hi, I'm Ben, and this is the house I built out of shipping containers. Now, I've been interested in shipping container architecture for quite some time, but I had a really hard time finding good information about how to get building permits or how much would it cost. Well, we did the research, we documented everything that we did, and now we're so excited to share with you what we learned. So check it out.
This is episode 3 where we'll install the doors, windows, and insulation. One of my favorite design features is this pair of JELD-WEN Bi-folding doors that we installed parallel to each other. Overall, we tried to keep the amount of glass at a minimum since that adds cost, and wherever we add glass we have to cut away some of the container. But we did splurge on this one dramatic moment that allows the inside and outside of the home to merge together. So when we left off in episode 2, we had just been installing these steel frames for the openings for these big doors. I wanted to create a little more visual separation between these doors and the corrugated metal. So I welded some 1/8 of an inch thick plate steel to the tube steel frame. I did this on the south side, and even though the motivation was primarily aesthetic to create some visual relief, this will provide a little bit of passive solar shading as well. We lifted the top piece into place so that we could get a precise mark for the length and then cut it and welded it into place. We cut the side pieces at a slight angle so that when we welded in the top piece, it would be sloped to shed water. Now typically in an environment like this, I would install much longer overhangs, but I'll explain my thinking for these shorter ones in the design notes at the end of this episode. These JELD-WEN Bi-folding doors came unassembled, which made them easier to ship. Prior to assembling the frames, we had already installed some strips of 1-inch thick wood that we will set the door frames on. We moved the frame into position, checked to make sure it was level, and then screwed through the frame and into the wood surrounding it. We added shims where needed and were careful not to overdrive the screws and bend or tweak the frame. I will post the full specs for these doors on the Modern Home Project website. Once the frame was secure, we could install the door panels one at a time. Now I like bifolding doors because they create such visual drama because you can open them all the way up. They can be, however, a little bit more finicky and difficult to operate than, say, sliding glass doors. As with most things in life, there's a trade-off, but with this project, we decided to go with the visual drama and really capitalize on the views since this was going to be primarily used as a vacation house. Now, there was some gaps between the steel frame that we welded in and the frame for the doors. We used fire-resistant spray foam insulation to fill in these gaps. We're going to cover these foam-filled gaps with angle steel and flat bar. We sprayed the pieces first with rusty metal primer and then welded them in place. We used this piece of angle steel to hide the wood underneath the door frame and then welded these really thin 1/2-inch pieces of angle section to the tube steel frame, and that just covered up those gaps around the sides. We used a piece of flat bar to hide the gap along the top. The sparks and splatter from the welding can damage the windows, so make sure you protect them. We were priming the backside of these pieces of metal trim with rusty metal primer. We had a few people suggest that we should be using a weld-through primer, but then we also heard that these aren't that great, so let us know your opinion in the comment section below. The rest of the doors are all swing doors that have glass panels in them. These are also from JELD-WEN. Once again, it's just about getting them nice and level, using shims to stabilize it, and then screwing through the door frames and into the wood around it. Every door in this house is technically a patio door and has glass in it. I just figured if I was going to take the time to cut an opening, I might as well be letting some light in. We used a few different types of great stuff spray foam insulation for this house. The reason we used a fire-blocking foam on the outside gaps is so that it wouldn't catch on fire when we welded on the steel trim to cover it. While I was waiting for the foam to expand, I trimmed the shims using a multi-tool. Tony had used a 2x8 underneath this door, which was wider than we needed, so I drilled a hole and then trimmed it with my jigsaw. I'm going to slide a piece of angle steel over the wood but under the door sill, and I used a chisel just to shave the wood down a little bit so it would fit. I cleaned up the metal and then welded it in place. The foam had expanded, but there was still a few gaps, so I just went in one more time to fill those in. I find that it's easier to do it in multiple passes than to try to overspray and then have to clean up all that mess. Once the foam had fully cured, I took a knife and trimmed it flush to the door frame. Now I can weld in a piece of angle section that will cover that gap, and a piece of flat bar at the top. There was still another window to do, and we did this the same as before, just applying some caulk on the inside of the steel frame, and then securing the window through the nailing flange with self-tapping screws. If I was to do this again, I think I would have installed the windows from the outside, and then created a second trim piece to cover the nailing flanges. With the window secured, we then added in additional 2x4s around it, and then screwed through the window and into that wood. Now for the inside gaps around the windows and doors, we used the window and door grate stuff. This version is formulated so that it won't overexpand and bend the window and door frames. We also took regular grate stuff and started foaming around all the framing. We really focused on the irregular nooks and crannies that would be difficult to fill with rigid insulation. This spray foam is helping to seal up all the little gaps in the construction, which will greatly reduce our air infiltration and improve the energy performance. We also started the electrical rough-ins, which involved installing all the electrical boxes and running the wires. This is the last chance to walk through the entire house and really make sure you have all the switches and outlets exactly where you want them. Typically for a design like this, I would specify spray foam insulation, but since we wanted to do it ourselves, we chose to use rigid insulation, which is easy to cut with a box cutter. We're going to use a combination of 2-inch thick, 1-inch thick, and 1/2-inch thick rigid insulation to fill in the gaps in between the 2x4s. For the ceilings, we started with pieces of 2-inch thick insulation, which we put on top of the double sill plate, and they kind of fit nicely up there. Later we taped in between the seams to seal each layer. Now no one on this team had ever built a shipping container house before, so we were definitely learning as we went, and one of the things we liked to do was to build ahead on one small area of the house. This way we could kind of test out our construction systems, see how everything would sort of go together, and then make better informed decisions as we applied it over the majority of the construction. So we insulated this one end wall and then sheathed it with 1/2-inch thick OSB. Later on we would switch to plywood because it has a little bit less formaldehyde than the OSB. Now some of the biggest gaps are between the corners of the steel containers and the wood framing. And here's where I made a real big mess with spray foam insulation. I was going around just sealing up all the nooks and crannies, and I kept trying to spray more foam into that big corner gap. I would spray some in, move around to other areas, and then come back and spray a little bit more in, and then it started spreading and getting kind of out of control. Jesse came in to start measuring and cutting the insulation panels, and if you keep your eye on the pile, you'll just see it keep growing and growing and growing. Now a number of things went wrong. First, we just sprayed in too much, too fast. Also, the air out here in the desert is quite dry, and spray foam cures a little bit better if there's a little bit of moisture. So we learned that applying a little bit of water with a spray bottle helps the spray foam expand and fill out these bigger gaps. To fix this, we also took a bunch of scraps of rigid insulation and stuffed them into the gaps first. This way there was a little bit of structure for the foam to go around and hang on to. There you go, all filled up. We would slide in the first piece of insulation, apply a little bit of spray foam around the edges, and then add in the additional pieces. We filled in all the gaps, and then sprayed around all the electrical boxes as well. Now we already have some insulation in between the steel floor joists, but we want a layer of continuous insulation on top of it. So we're going to apply these subfloor insulated panels. These are a really cool product that are often used for remodeling basements, and it's just a layer of OSB laminated to foam. They cut easily with a circular saw, and then you can just glue them down to the floor using Liquid Nails Subfloor Adhesive. For the pieces around the door, we trimmed just the OSB part of the panel so that the foam would slide right underneath the door's threshold. I really liked this system. The 2 foot by 4 foot panels were really easy to handle, and the whole installation went really quick. Now we ran out of these panels for the third container, so we decided to come up with a different way to do it. So after we screwed the plywood floor panels back down, we nailed in 2x4s on the flat side every 16 inches on center. We then filled in these gaps with pieces of 1.5 inch thick foam, and then nailed down plywood on top of that. Now in general, my strategy for this project is to use my hired labor to do the more conventional parts, like the 2x4 framing, applying the plywood, and insulating, while I focused on the steel work. And I think this strategy sort of makes sense because in most areas it's easier to find affordable framing labor than it is to find affordable steel workers that have welding experience. I wanted to make a thin plate steel frame to go around one of the bedroom windows. So I cut and welded pieces of plate steel together, but I was careful to make sure that there was a bit of a taper on the top and bottom panels. This way water that lands on it will drain right off the edge. I prepped a tube steel frame and then welded on a piece of angle steel that will serve as a ledge to support this big trim piece. I used magnets to hold the piece of angle steel level and then welded it to the tube steel frame. All of the welding that I did on this project was done with my Forney 3-in-1 welder. I can't recommend this machine highly enough. It's affordably priced, powerful, and incredibly versatile. We lifted the trim piece into place and then welded it to the tube steel. We still didn't have power to the site at this point, so all this welding had to be done with a generator. We used this Ryobi generator to power all the heavy-duty tools and the welding, and then we used our Goal Zero system to keep all of the batteries charged for all of our handheld power tools. It was an effective combination because it allowed us to keep the noise down when all we needed to do was charge batteries, but then still have the power when we needed it. Shipping containers have holes so that they can be picked up with forklifts. So I cut some pieces of 1/8 inch plate steel, primed the back of them, and then welded them into place. The plumbers cut some notches into this bottom beam in order to fit in some of the elbow pieces for their drain pipes. So I just took some of the extra corrugated steel and cut patches for those. There are some really big openings at the ends of the 40-foot containers, so I cut long strips of 1/8 inch plate steel and I welded on 2 small pieces of angle steel so I'd have something to clip my welding ground onto. The structural engineer required 1/2 inch sheathing on all the interior walls. So while I was patching up the steel, the rest of the guys started cutting and nailing in all the plywood. Now this does seem like overkill to me, but I'm not an engineer and I couldn't find an engineer that would sign off on it without specifying this type of sheathing. The good news is that it'll be really easy to hang pictures in this house since there will be plywood right underneath the drywall. Typically this type of sheathing is applied on the outside edge of all the 2x4s, but because we started with a complete container, that would have been a little bit difficult. In our location, all new houses have to have sprinkler systems in them for fire suppression, so we had to wait for a specialty installer to come and install all these pipes before adding additional insulation around them. We installed another layer of insulation over those pipes with just the sprinkler heads sticking through. Now there are a lot of tasks you can do yourself to save money, but I highly recommend hiring experts to apply gypsum board. An experienced crew is so fast at it, and they're going to do a much better job at mudding, taping, and sanding than I could. Not only would I be struggling physically with the dexterity for each one of these steps, I'd be overthinking each process as well. This crew was able to do the whole house in just 2 days. They screwed on the panels, mudded and taped the seams, put trim on all the corners, and then did a full skim coat over the top. The skim coat is definitely something I wouldn't have attempted as a DIY project, because if you aren't able to apply it perfectly flat, you're gonna spend a whole lot of time sanding.
Hello. In this edition of Design Notes, we're going to go over what I learned about reinforcing openings in shipping containers. We're going to check out the insulation details, and we're going to talk a little bit about passive solar overhangs.
Let's start with why I think angle steel is a better option for reinforcing openings than tube steel. The width of the corrugation on a shipping container is pretty substantial, and that makes it a little bit challenging to get perfect cutouts. Even when I went nice and slow, I occasionally had gaps ranging between 1/8 of an inch and 1/4 of an inch. It's also very difficult to hold them in the right position while you're getting ready to weld them because there's nothing for the tube steel frame to rest against. The corners of tube steel have a radius to them, so even if you cut the openings perfect, that radius will slope away from the corrugated metal that you're trying to weld it to. Another issue that's totally fine for this climate but isn't ideal overall, there isn't any overlap, and that means we're relying a lot just on the sealant. With the angle steel, we have 3 inches of overlap, so even if the sealant failed, it would be hard for wind-driven rain to get up past that flange. That flange also makes the installation process a lot easier because it gives you a positive stop where you can push the frame all the way up against the corrugation. And even if you cut the hole a little bit too big, you're still going to have a lot of these positive stop points to weld the steel together. The gaps between the corrugation and the flange on the frame can be filled with closed cell spray foam. I also think the angle steel just creates a better looking frame from the exterior. Alright, let's move on to insulation. For the walls, we were able to get between 3 and 3.5 inches of insulation, which gets us to about R19 to 21. For the floors, we hit R46, but remember, the majority of that has steel going through it, so it's not going to be as effective as the continuous insulation. For the roof, we hit a total of R48, and 26 of that is continuous. The floors of the container came with this really thick plywood. There are steel beams underneath it, and in there we just filled in with a lot of rigid insulation. Mice and other critters sometimes like to burrow through rigid insulation, so we made sure to seal along the bottom side steel rail with some Quikrete precision grout. Above the plywood is where we get our nice continuous insulation using the OSB insulated panels. The sill plate ends up beneath this panel, so we added some short pieces of 2x4 in between the studs just to give us a little bit more material to nail and screw the plywood and gypsum board to. For the roof insulation, it's all about working around the structural connections. The first continuous layer of 2-inch insulation sits on top of the double 2x4 top plate and gets pushed right up against the 2-inch tube steel. We used 2x4s on joist hangers for the ceiling and was able to get another continuous layer of 2-inch insulation right above them. We shoved an additional insulation in between the 2x4 ceiling joists, but some of this had to be cut out to make room for fire sprinklers and the ceiling lights.
Passive solar design is all about understanding how sun angles work and designing a building so that you let more sun in when it's too cold and keep the sun out when it's too warm. This is typically done with overhangs above any windows or doors. On the south side of a building, the sun will be at a steeper angle during the summer, and then it'll drop to a little bit lower in the winter. So you can size overhangs to keep the sun out during the hot summer months, but still let it in to warm up the house in the winter. Typically, I would select the length for these overhangs from a chart of best practices. Or if we wanted to get really precise like I did with my architecture firm, we would actually build a full energy model to really simulate how the building's going to work. But in both cases, you're taking in a lot of assumptions. And with this project, since I'm actually going to be able to live in it and measure it, I decided to go a little bit more conservative onto overhangs at first, and then really measure and see how well they are working and only add a little bit more as needed. It's a really cool opportunity to design in real time and constantly improve the building, and I'm super excited about measuring these things and tweaking and adjusting them. Now obviously the sun angles are going to be different in different parts of the world. This is a handy chart that I created with one of my previous design companies that kind of separates it into a few basic groups and then gives you really good rules of thumb for sizing your own passive solar overhangs. I'll post this chart on the Modern Home Project website. Thanks for watching episode 3. We're still working on episode 4. We should have it for you soon. I know you've all been waiting, and we appreciate that. In episode 4, we're going to cover the HVAC systems and some of the other technical aspects of the home. So stay tuned and make sure you hit that subscribe button if you haven't already. Thanks. Bye.